Ladies and gentlemen, so we're going to look at integrated development environment and code maintainability. So kind of a two-pronged attack here, okay? So what we're going to do is look at the kind of principles behind, well, writing code and then fixing code when it's broken, but also making sure that our code is well written to begin with, so we have fewer bugs, and if we do have a bug, they're easier to find due to code maintainability, good commenting style, modularity, and all that kind of lovely stuff. Okay, so that's what we're going to do today. So let's crack on. So what do we mean by maintainable code? What is an IDE? And what the key features and methods of debugging? I'm going to show you also how to use the Python debugging tools at a very, very high level. I'll be honest with you, I don't tend to use them very often. It's only when I'm writing really complex code and I can't work out where the bug is. That's when I tend to employ it, and that's probably true in real life as well. Sometimes they are quite time consuming, which is why we tend to use the debugging tools as our kind of like, I wouldn't say last resort, but as our serious bug spotting rather than our basic bug spotting, like I've missed the bracket or something like that. Okay, so that's where we're going with this. So maintainable code. Now this is no different to GCSE in all honesty, apart from we're adding this IDE and modular code. So sensible variable names, that goes without saying. You must avoid using X's and Y's where possible, and the variable you should use should be a descriptive of what it's containing. Okay. The bigger the project, the more important that is, because if we start writing code where there's lots of X, Y's, and I's, and J's, it makes it really hard to read over time, especially if you're coming back to code maybe like 6 months later, or you're coming to someone else's code and you're trying to kind of work out what's going on. Indentation in Python is a necessity, so it's kind of a moot point, but in other languages such as Java and C++, so for example, in Java, when we write an if statement, okay, we have to put the if in there, a bracket, A is greater than B maybe, and then we have a curly bracket, and then I might put my system.out.println. Sorry for the bad handwriting. Okay, but notice I've not indented it here. Okay, that's perfectly legitimate in Java and C++, things like that, but it does actually make your code hard to read. So actually, if I want to do this properly, what I really should do, oops, I'm going to get rubber, there we go. What we should really do is start my writing here. So just tab it in. The biggest difference between Java and Python in terms of indentation is Java is optional, okay, but good practice. While Python, you have to have it, otherwise it just won't run. Okay. Comments. Most students hate writing comments, but in industry you must write comments because, again, you may not be the one debugging this code. You may not be the person in maintaining it. You may not even be there in 6 months' time because you go to another job. And for example, let's say, I mean, this generally did happen to me. I wrote some code for a company. I won't say the name of the company. But I wrote some code for it, and I obviously put comments in there, but even my comments weren't detailed enough. They maybe didn't explain the code well enough, because when I did leave them, I had a message maybe 2 weeks later saying, please could you come back and help us with this, because we don't understand the code you've written. Could you explain it to us and help us out with some coding, which I did for a price, obviously. I forced them to pay me double money. So you know, it happens in real life. So if I write code, it must be well commented. Obviously, us programmers don't like commenting, which is what happened in my case. But it's important for maintaining the team collaboration. So moving on to modular coding. Now this is something we've been studying in class a lot. So we're using functions, and more importantly, as time goes on, using objects and classes, splitting our code up so each module has a specific purpose. Now if we do that, then it isolates bugs a lot better. Okay, so if there's a problem with my function, well, I've got to go to one function and fix it, and then it will just fix the rest of the program. Also, it means they can be tested and developed independently of each other, which means we can test it more thoroughly as well. Okay, so modular code is absolutely crucial for maintainable code. Okay, when you go, again, I'll give you another story. Why not? It is a Tuesday. When I was, again, same company actually, I was in a code review, and in code review, what you do is look at someone else's code and you give them feedback. Now, the code I was reviewing was written by someone who was actually senior developer, so they should really have known better. But they had a function which was something like 10,000 lines of code. It was just humongous. I might be slightly exaggerating, but the function was just ginormous, and there was so many nested if statements and while loops. It was absolute mess. The feedback was this needs to be modularized because there's no way we can maintain this. If there's one tiny mistake in one of those loops, it's kind of going to break the entire 1,000, 2,000 lines of code, which is not good. Okay, this is not this can't be maintained. Sadly, Muggins had to refactor it all, which basically means rewrite it, which was great. But it was what it was. But then I turned it into lots of functions, which all can be tested differently and separately, and also unit tested. This is not something you do in A level, but essentially it's automated testing on your functions, and it's just a common practice nowadays. And yeah, so modular code is actually super duper important. So now we're in A level, it's important to consider the other naming things that we have. So as well as variables, we also have constants. So for example, I might have pi. If I just went p equals 3.14, that's not very descriptive, is it? But I might have pi equals 3.14. Okay, so it's a very small change, but you can hopefully see that using a constant in this scenario is really good, and also it is much more descriptive by just adding an I on it, basically. Functional procedures, obviously, these must be named really, really carefully. You can't just simply have lots of functions called X because it will be very descriptive. So your functions explain what they are doing as best they can do in the name. Okay. One little gripe I have is that when you use libraries written by experts, so-called experts, they don't always name their functions really, really well, and sometimes they're really confusing, and it probably made sense to them at the time, and if you understand the library really, really well, it probably does make sense, but coming into something new, not so much. Classes obviously must have sensible variable names as well as objects. Any labeling you use when you're doing things such as little man computer coding and assembly and all things. Essentially, if you name something, give it a sensible one. Okay, nice and simple. So why do we do that? Well, the answer is really simple. It makes it much more easy for people to read your code. Okay. Again, another gripe I have lots of gripes about code, as you probably gather, is that when you go on the internet and you look at Stack Overflow, for example, things like that, you have some people who just insist on using I's and J's and K's and things like that in their code, and the code becomes immensely complicated, and it's almost like they're doing it on purpose to make it look like they're clever, when actually, they've just made something overly complicated for no reason. If they use sensible variable names, the code will be more understandable, more readable, and more maintainable, which is obviously what you expect from an industry expert. It massively helps bug fixing. I can't tell you the amount of times I've gone through code and when they haven't used sensible variable names and just scratch my head going, I'm not sure here, and I have to kind of go through the debugging phrase and then realize, that's what that variable means. Okay, now I get it. So if you just name things in the first place, you don't have that issue. And most companies insist on it. Okay, so most companies, when you code for them, they'll have industry standards that you have to follow. It's very, very, very common. In fact, I would say essential to developing in a team. So you have to follow these conventions. So, for example, some companies might, if you had two words, let's say my two words are A and B. Okay, you might have A lowercase, B uppercase, or maybe A underscore B. Okay. And that will be a standard, and you must follow that so everyone else in the company will understand your code better. Okay, so if we all follow the same set of rules, it makes it easier for people to understand. Okay, I always forget what those things. Well, I know one of them's camel case, and I always forget which one around it is. I think that was camel case, but please don't shoot me if that is wrong. So apologies for that. Comments are super duper important. Now, it's something programmers hate doing because we just do. I think anything English related, we tend to run a mile, I myself included. So these are essentially blocks of code used to explain stuff. Okay, so in Python we use a hash. In HTML, it's a delightful kind of funny exclamation mark, minus sign or dash. In pseudocode, in JavaScript and Java, in C, we do that one. Also in JavaScript and C and stuff, you can do I think it's slash and star, and then star slash. Okay, that will also add comments in it. Although not strictly a comment, you can do this in Python. Do 3 quotes, and that will allow you to have multi-line comments. It's not really a comment, but the Python will just ignore it. But it can be used as a comment. Comments are required to help you improve the readability of your code. Okay, so they're there to help understand your code for when you come back to it later on, or when another team member comes to use your code, or debug your code, or maintain it, or adapt it. Depending on what the case may be, it helps them understand it. Okay, so it's absolutely crucial. Now, as a kind of principle, you don't comment every line of code because that will just take too long. You tend to comment the most complex parts of your code, and absolutely, you always comment the functions. Okay, so you explain what the function does, what the parameters are, and what the return is. That is absolute default. Most companies will have what's called a boilerplate, and a boilerplate essentially is a structure for your comments at the start functions. And in fact, most IDEs will have a feature where it will add the boilerplate for you, and you just simply fill in the blanks. Okay. So, what should I comment? Absolutely function definitions, parameters, purpose, and return. That is absolutely humongously important. And that's what I was referred to as a boilerplate. So you might have something along the lines of this. This is just one that I remember. So you might have like something like this, lots of hashes on the line just to identify it. I've forgotten how to write hashes. Then you might have the purpose, the parameters, and the return. Sorry for my handwriting, it's quite hard to write on the screen like this. And then you'd write down the information there, and they will end with some more hashes. Okay, just to identify it as a block. And obviously these will start, because it's Python we're talking about at the moment. We'll start off with hashes as well, so it's comment. Okay, they block it like that just to make it really stand out. Okay, that's the purpose behind it, and it's so important that it sometimes gets added automatically using certain IDs. Complicated while loops and if statements must be commented. So if you've got something where it's maybe the core part of insertion sort, for example, where it's shifting things, you might put comments in for that one. Start any key algorithm to explain what the key algorithm is doing, like if you're doing Dijkstra's shortest path, for example, or bubble sorts or things like that, you might explain what's going on. And then normally, if any external libraries are called, maybe not every single library call, but when you start using something, just to help understand that you are using this library and for what purpose. Don't comment simple parts of your code like a equals 5 because we can tell what's going on. It's not a big deal. You may want to say why the variable starts at 5, possibly. If it makes a difference to the algorithm, absolutely do so. But what I'm trying to get at, you don't comment to every line of code, just things which are important. So why? Well, comments help explain complex part of your coding. It enables others in your team to understand what you've written quickly, and it is absolutely useful, trust me, especially the function ones. It also allows you to remember what code you've written when you come back to later. I certainly have started a project off, got distracted with schoolwork, then come back to it and been like, what on earth did I do this for? I can't remember. And I've written some quite complicated code in the past, and I sat there going, I can't remember. I really can't. And I have to reread more of my code, work it back out again. And they go, now I remember, and it all comes back again. But I've wasted like an hour trying to work out my own code. So, as I said, I'm not great at commenting, like most programmers, but it's super important, and I really should do better. I really should. So indentation, as it said, so here I've got 2 examples. Hopefully you can see why the one on the right is more readable. Okay, you can see what code is in what. When we write pseudocode, we must indent as well, just because it makes your code readable. If you're doing C in Java and things like that, you must also indent just because it makes it more readable. If it's Python, well, you have to do it anyway. Okay, so I'm not going to spend much time talking about indentation. So compound statements such as if statements, while loops, and functions which go over multiple lines must be indented correctly. They may in turn require you to indent further, so you might have a while loop inside a while loop or a function with a while loop inside it, etc., etc., and you must indent to make sure that you show exactly where things are. By indenting our code, we can quickly see where things start and end, and that's really, really super duper helpful for looking at large sections of code. And obviously, it's fundamental for Python, so you have to do it anyway. So, modular coding. Modular code is all about functions. When a task is first encountered, you normally decompose it like we have done in class. And this obviously helps you decide which modules you are going to require in your system. Your module then may require multiple functions in order to get it working, which perform key parts of functionality. And then you put all these modules together to get to your final result. So why do we do this? Well, we've already talked about this, but modules can be tested individually and ensure correctness. Now, in industry, there's something called unit testing, where you write some test code, essentially, which will automate some testing. And then these tests can all be run. So I'll give you a more concrete example. So when I worked in a big team of 50 coders, each of us were working on different parts of the program, and we'd have these unit tests which run. So if I submitted new code to the system, the unit tests will all run to make sure that my code doesn't break anything. If my code breaks a unit test that was previously working, then my code will be rejected. I then have to work out why it was causing that unit test to fail before I can resubmit the code. Okay, so it's just ensuring that any code submissions don't break the entire system. I've certainly been in projects where that has happened, and trust me, everyone gets very, very cross with you when you break their code. Okay, so absolutely, it's important. Modules can be coded by different members of the team, which goes without saying. We've talked about that before. Modules can also form part of prototypes when we're doing things like Agile and RAD and all those kind of other software methodologies which you've now studied. It will support that. Also allows us to make complex algorithms to be simplified into high-level abstractions. So a sequence of function calls each does part of the algorithm. So rather than having like a massive 100 lines of a really complex algorithms, I can break that little algorithm into steps. Maybe it has 10 core steps, and each of those steps maybe has, I don't know, 50 lines of code to get it working. Those can be split up into functions, and then I can have just almost like an overview of the algorithm in the main part, and each of those then call different functions. That is very, very common, and it's good practice to do so, because then we can focus on individual parts of the sub-problems, and then obviously test those individually, and ultimately make sure the code is working as a whole. So coding modules, now one of the key things to remember is that sometimes modules link together. So for example, let's say we have two people coding two different things, module A, module B. The input to module A might produce an output. That output then goes into module B to produce a final output. So you have a sequence of modules. That's very common. So I'll give you a more concrete example. Imagine my job was to write the graphical user interface for a form on the web, and then someone else had the job of actually storing that data into a database. Okay, so I write the user interface and pass through the values, and then that other person will then take those values and store it in a database. Now, if we don't agree on how my output's going to come out and how their input's going to come in, then when we try and put these modules together, they're obviously going to break. Okay, this is part of thinking ahead. Okay, where we think about the input and output to functions. Okay, so where does the data come from? Has any validation happened on it? So for example, have I validated the information before it's got to module B? Have I done anything along those lines, or am I just showing raw data? If there's a first name and last name, have I combined the two together to pass to it? If there's an email address, have I checked see if the email address has got an @ symbol in it? You know, things like that. We need to agree up front. Okay, so we have to think about that before we do it, and that's part of coding modules. Modules also could be laid out like this. So I might have an overview module A. So imagine this is the complex algorithm as an overview. So maybe like quicksort, for example. And then we have maybe two parts of it. You might have partition, and I'm not really sure what the third part will be in quicksort, but there you go. But imagine that. So we have module A, which is calling module B, and then schemes about the output. That output is then used as the input to module C, and then it gives the output to module A. Module A does one last thing to it and then sends it out as output. Okay, so we have that kind of pattern of things going in and out. Okay, so it's absolutely fine for a function to call another function, to call another function in order to get a job done. Okay, it's very, very common practice. So now's the time to pause the video and actually have a go at some questions. So exam questions are on the class charts, so please do that. If you're watching this on YouTube, I apologise that you won't have access to that stuff, but if you Google, you'll be able to find some questions on it really fairly easily. Okay, so it's not that hard to find them. So my students, please, could you have a go at those questions on class charts, please? Okay, do submit them and upload them to show me you've done them. Okie dokie, so the next stage of this is looking at debugging. Okay, so part of an IDE is to do debugging. So we're coming back to the idea of an integrated development environment. So when we have bugs, we have 3 types. Now, this used to be a question on the exam, but now it's not. But there you go. But this is the 3 types. So syntax errors, this is where your code just won't run. Okay, so you have syntax errors such as, I don't know, you misspelled print, for example. So this is stuff that will stop your code from running or being compiled. Logic errors are stuff where the program will run, will give you the wrong answer. And runtime errors are things which are outside your control. So for example, I don't know, if you've got a web browser and the internet's down, well, it can't use the internet, can it? So there's going to be a runtime error saying you must connect to the internet or have a network connection. So runtime errors are ones which you cannot control, but you must still protect against. Okay, so runtime. Debugging tools are part of an integrated development environment, and they tend to be used to fix logic errors and sometimes to identify runtime as well. And the key ones are, which one we're going to look at today, is step through, okay, where you can step through line by line, see what's happening with your code. Variable watches, which is used very much with step throughs, where you can see the content of each variable as it changes, and which is super duper useful. Breakpoints, where you can stop your code at a certain point, sometimes known as a trace point, and ultimately logging and account console output, so you can actually see what's going on. So, an integrated development environment might look like this. Now, you are probably used to using IDE or Genie for your development, and you'll probably notice some similarities in the sense of you will always have your code displayed a bit like this with nice colors. This is known as pretty print. Pretty printing is there to highlight key terms and keywords, and it just makes reading code a lot simpler, and that's a really, really key feature. Obviously, being able to run your code and you see the output of your code is just a default kind of thing you need to be able to do in IDE, and then be able to translate your code to run it. That's a part of it. Some more complex IDEs, like this is PyCharm, for example, will have an ability to have multiple files in a module. So if you're in a real development environment and you're in a real project, you're more likely to have multiple Python files and multiple folders with multiple Python files inside it. And when you're doing it, you know, this number of files can be absolutely excessive. So you can have hundreds of code files inside a single project. That's easily done. There's lots of other things you can do with it. So you can have debugging and be able to run it. So down here, you've got debugging tools over here, and I'll come on to that in a moment. You can also have virtual environments where it sets up separate environments, so you can do your testing and have separate libraries installed for separate environments and things like that. Okay, so there's lots of features in an IDE. So some of the core things which we've already talked about: syntax highlight, pretty printing, debugging tools, being able to have multiple coding files, and also version management. I didn't mention this one. Version management is really, really useful when you're in a bigger project and you're working in a team. Because what happens is you can have your own local copy of the code, which is kept updated. Okay, so you can kind of get the updated code. You can then check out code. Okay, what that basically means is you have exclusive access to that file, and everyone will know you've got exclusive access to that file. You make your personal changes to it, and then you re-upload it and check it in. That stops you from having situations where 2 people try and edit the same code, and then you have issues with merging the code back together. Okay. Also allows you to roll back code. So let's say I submit a program which breaks the rest of the code. then I can roll back my change, fix it, and put it back in again. Okay, so you can roll back changes and go to an earlier part. There are other features of version management, but I don't really want to go into those at this stage. So, debugging tools are things that I want you to give you practical experience of. So here I've got some code which is broken. Okay, it's not going to work. Okay, so when you run this code, it should give you the answer to 24, and this one does not give you the answer to 24, it gives you the answer to 12. Okay, so this code is broken, it's not working. What we're going to do is use step through and variable watching to actually find the bug and see what the problem is. So we have step over and step into. Step over will run a function without stepping through it line by line. Step into will go into the function and run it line by line. Okay, so in this example, if I'm running this factorial function here, I want to step into it so I can actually see the line by line what's happening with it. If I didn't want to see the line by line what's happening in factorial, I can jump over it. In this scenario, because the bug is in factorial, I clearly want to jump into it. Okay. Variable watching is what you'll use as you're doing it. So as you're stepping through your code, running it line by line, you want to see how these variables are changing. This is going to give you clues on how your code is working. Okay, so when you've got a logic error, it's a really complex one, you can't work out what's going wrong, you can do this technique, you can watch your variables and see how they are changing over time. So as we step through the first loop, we can see that the variables we have has counter of 2, n equals 4, and total equals 4. Okay. After the first loop, okay, the total should be 1, because what I should have done is times it just by a 1. Okay, that's my first loop there. Okay, so the answer should be 1, but I've got an answer of 4. So can we see what's wrong? Okay, if not, that's fine, because we can do some more stepping. If you can, then obviously we can fix it. So what can we do? A breakpoint, or a trace point, as it's called in some circles, is a way of stopping your program at a certain point to actually start this step-through process. Okay, so in PyCharm, for example, we can add a little red dot. In Python, when we're just doing like in Genie or IDLE, we have to write a line of code, and I'll show you that in a moment. And every IDE has a different way of doing it. A red dot tends to be the most common. So what it means is you can stop the code at a certain point. So when the code runs, it's going to stop here, allow me to do step through, variable watching, and all the other lovely stuff we can do. Okay, so I can do breakpoints multiple times. Okay, so I can put a breakpoint maybe at the start of the loop and at the end of the loop to see how the code's changed. Rather than having to step through each line individually, I'll just see start to stop to see what the values were, go to the end of the loop, see what the answers are there, and see if it was what I'm expecting. If not, well, I can step through the next time. Okay, hopefully that makes sense. So I'm going to show you how to use the Python debugger if you do not have a more advanced IDE such as PyCharm or something along those lines. So I'm using Genie, but this will work in IDLE or actually anything in Python, to be honest with you. So the first thing I'm going to do is import PDB. Okay, this is the Python debugger. P for Python, DB for debugger. Okay, so like you'd import random numbers or a Pygame or things like that, you do the same for this. Okay, so the first thing we need to do, and the easiest way to use this, is to do something known as a breakpoint, okay, or trace point. So this line of code here, this pdp.setTrace, what it does is when the program runs, it will stop at that point. So I'm going to show you what I mean. So at the moment, I've got it commented out. So I'm going to run the code. Boom, there's the answer. Okay, and as you see, the answer is wrong, by the way. So I'm going to put that in there, and I run it, and you can see it stops. And now, what do I have? Well, it says counter equals 1. So what it's done is it's at this line of code. So I can now step through this line by line. So I'm going to press N and hit enter. Okay, N's for move on to the next step. Okay, and now it's run the counter 1. It's now on total equals 0. So I'm going to press N again. Okay, now it's on the while loop, press N again, and you see it's now running this line by line. The difference between S and N, okay, S is step forward and N is run the next step. So the big difference is if there's a function S will actually jump into that function, run the individual lines of that function, and you can step through each line. N will just skip over that function and bring the result back. Now, sometimes you want to step in to a function, sometimes you don't. Because of the fact we're not using lots of functions, it will be mute for this purpose. Now, at the moment, we can step through, but actually I want to see what the contents of the variables are. Okay, I want to see the variables. Now, stepping over code is all good and well because we can see the point where things break, but actually we also want to see the variables. So what I'm going to do is I'm going to do display and total. I'm also going to do display and counter and display and n. What this does is you can see straight away it's showing me the contents of those variables, okay? But more importantly, what it's going to do is it's going to show me when they change. So every time one of the variables change, it's going to show me new values. So I'm about to run total equals total plus n, so the total should change. So let's press n. Okay, can you see it now says display total 4. The old value was 0. So show me how it's changed. Okay, like it just keep doing this. Okay, so it's showing me that the counter's changed. I'm now on the loop. Okay, now total's changed. Okay, you can see now it's added 8 onto it. Press N, the counter is 3. It runs total now. Now total's 12. You'll notice that it's going up in 4s. Now, if you cast your minds back, this is factorial, okay? It should be, it shouldn't be doing that, okay? It shouldn't be adding 4 each time. It's definitely wrong. So straight away, we've got a problem with this line of code here, the total equals total plus n, okay? Now that is wrong, that's not working because we can see we're getting the different values, okay? So the total we should be getting is not the same as the total we are getting. So this is how we can use debugging tools to actually work out what's going wrong. We step through the code, we display the variables, do a variable watch to see how they are changing, and then work out, are they changing the way we expect them to change? If they are, brilliant, that means that's not the problem. If they're not, well, brilliant as well, because I found the bug and I can fix it. Okay, so that's how we can step through code and we can use variable watches to do it. Okay, so I'll put these commands in the PowerPoint as well so you can see them in a bit more detail. Okay, so using the Python debugger, if you don't have a more advanced IDE like PyCharm, what you do is really simple. You import it like that. Okay, so import PDB, and what that does is it gives you access to the Python debugger. So very similar to how you do, I don't know, import random and import Pygame, things like that. Then to actually set a breakpoint, it's the same as having like the red dot in PyCharm. Okay, you put PDP dot set trace. Okay, so in Python debugging terms, it's called a trace point. Okay, so that will stop the Python debugger at this point, and then you can do your step through and things like that. So when the debugger does pop up, it's command line based, so you have to enter text commands. They're really simple. S is step forward, N is step in. So sorry, step out, over. So this is step in, this is step over. Then A, display function arguments. That can be sometimes quite useful. So what that means is display the parameter. Okay, in this factorial example will be n. And then also a display followed by what variables you want to look at will show you the contents of variables. Okay, and every time they change, it will give you the new value of it. That's really useful. So for example, I would enter display total when I was running the factorial example to be able to see how the total is changing. It always shows you all the new values, which is also very useful. So if I went through that and worked out what the problem is, here would be my fixed code. So there's a number of bugs in this code. First of all, total had to start at 1 because I'm multiplying. Okay, I was adding and I should be multiplying. If I multiply anything by 0, it's always going to be 0. So that's why that starts at 1. It was not looping over correctly, so it was ending at the wrong point, which is why I had to change that one. Or technically I could change that one, I guess. But it wouldn't necessarily give me the right answer. So no, I don't want to change that. I just realised that, sorry. And then obviously I need to multiply it. And also instead of adding n, I want to multiply it by counter. Okay, because if I multiply by n each time, well, n is 4 and n is not changing, so that will give me the wrong answer. Okay, so that will give me the correct answer of 24 and it's correct factorial code. So I've uploaded a Python program called Bugs. What I want you to do is open up it in PyCharm if you've got PyCharm. If not, open up in your IDE or whatever you use at home. And also, if you are using IDE, make sure you're importing PDP and using pdp.setTrace. If you're not sure about that, look through this video to see the code again. Okay, just go backwards, or you can. Sorry. Okay, being in school, you have to deal with that. So I can't be bothered with you doing this slide. So you can just have a little bit of giggle at that one. If you're not sure, check my video on the coding for that one, or Google it. It comes up almost immediately. So it's really dead easy. Okay. So, summary, ladies and gentlemen, there are three main debugging tools in the IDE: breakpoints, variable watching, and step through. Those are the more key ones you need to know about. An IDE is allowing you to do the following. It can allow you to obviously run your code, translate your code, and see the output of your code, manage larger projects and multiple files there, do syntax highlighting, and also allow version control. Okay, so hopefully that was useful.